All right, welcome everyone. Thanks for joining us in this final afternoon of this year's edition of the Hadoop Summit in San Jose. Excited to present for you today. I'm Ron Bodkin. I'm the founder and president of Think Big, and I've got with me Scott Reisdorf, who's an architect in our R&D team. And I'm very excited to share with you some of our experiences, what we're working on around integrating Spark with NiFi in building data lakes. So just a little background before I dive in. We started Think Big over 6 years ago, always with an exclusive focus of helping companies leverage Hadoop ecosystem technologies to be successful. And we continue in that mission. That's all we work on, is helping customers succeed with big data. We've grown quite a bit since we started. We're about 250 professionals worldwide globally. We were acquired 2 years ago by Teradata, but our mission and focus around the Hadoop ecosystem has never changed. And as you can imagine, over those 6 years, we've had a lot of experience helping people build environments in Hadoop. How do you put together data lakes? How do you organize the data? How do you scale it, make it work? And we started 2 years ago with a real investment in putting together a software development team to build frameworks and repeatability for how we deliver these systems. So we've done a lot with that, and I'm pretty excited to share with you the latest version of stuff that started with some of our big customer projects 3 years ago and has evolved. And really this year we incorporated NiFi and Spark and essential technologies, and we're really excited by what we've done. So I'll share with you a little bit about what are the requirements we see in managing data and building the lakes, some of the design and how we leverage Spark and NiFi, and then I'll really turn it over to Scott to spend the bulk of the time actually giving you a demo and showing you a little bit more in the details of what we've done. So you'll see some working technology, right? So requirements, design, and then a demonstration at the end here. So broadly, what people are trying to achieve in our customer base when they're building data lakes is they want to be able to have a central repository, put together all kinds of diverse data, new kinds of data with complex varieties, click streams and sensors from IoT and social data, et cetera. So they want to put together a bunch of different data, not forgetting usually hundreds or thousands of feeds from relational, in a central place where they can trust it without taking all the time to put everything and curate it and parse it and get it in a relational form. They want to have a raw data that's available together in one spot, make it easy to do some discovery and prototyping on that data, often have cost efficiencies, offloading some of the analytical systems, and a laboratory for working with exciting new analytic technologies with that data. Often, the economics of being able to try out new approaches to working with data. Spark is a very common technology for doing that kind of data science exploration. We're starting to see more use of deep learning technologies like TensorFlow, right? So there's a lot of reasons why organizations are building data lakes. Drive agility, faster time to value, better ability to work with all the data. To make it work, there's a few key principles that we see are absolutely necessary. One is you got to be able to automate, right? You need to have a DevOps mentality of your pipelines are automated, that there's a low overhead process of putting a pipeline into production. You track metadata when you put them into production, you can track what's going on. Having service level agreements. We all know that feeds depend on other feeds, that a modern Hadoop-based system has a lot of complexity, right? So you need to know, are you meeting your service level agreements? It doesn't do any good to do an analysis on incomplete data or stale data. That can exactly give you the wrong answer, right? So you need to track your service level agreements and know if stuff isn't working so you can be proactive. Governance in the sense of having ability to support different users having different roles in the environment. What is an analyst doing? What is a data steward doing? What is IT's role? What does a data scientist do? And make it easy to do discovery and experimentation in a lab environment that leverages the data that's in the lake that's trusted, but let you put in some of your own data, bring some of your own tools, right? So those are some of the key things that we see as requirements to succeed in building a lake. As an example that we see at the kind of scale, the kind of customers we work with and the requirements we see, we have customers where we've ingested thousands of flat files and relational tables, plus a number of streaming data feeds into the lake, right? They have a mix of incremental data and snapshot data. The first step is usually ingesting the data into HDFS and Hive, but then, of course, starting to transform it into more convenient forms, right? A classic example of this would be if you had raw data of events from a clickstream, you probably wanted to build some kind of a sessionized view where you can see a series of events for the same cookie or user ID or mobile device ID together. And always you're going to have a security requirements. You need to do some cleansing, encryption. basic hygiene like bot detection, validating data, all the while capturing metadata. Right, so typically, data lake projects start with getting the data in, then transforming it into a consumable form, and finally, how do we really enable analytics to leverage that environment? Right, so those are the kinds of requirements we're thinking about. With that in mind, let's talk a little bit about the design, how we've evolved some of the pieces that we use, right? So first of all, Spark. I certainly won't pretend to educate you on Spark. I have a feeling everyone here has heard a lot about Spark. How are we using Spark, right? We see it as incredibly valuable as a way of doing the transformations, of making it easy to do cleansing and validation, to do profiling of data. As you'll see, we even have a visual tool to help people do wrangling and let people explore and work with data on the fly, leveraging the power of Spark, but maybe making some of the power of Spark accessible to users that don't write Scala code, that maybe aren't even going to use Spark SQL. Now, NiFi is a powerful framework that you may have heard about here at this conference or elsewhere, or you may not have. You know, it came out, it was built at massive scale at the NSA. It's open sourced as part of Apache. And you know, it's something we think there's a lot of really good qualities. So we picked NiFi because we're very excited as a successor, as kind of an engine to make our data lake frameworks a lot more powerful, because it gives you really compelling visual drag and drop capabilities with lots of pre-built connectors and transformations. It has some of its own built-in lineage, and it's quite extensible, right? So we leverage it to let people build out pipelines visually. And Scott will demonstrate it and give you more details on NiFi in just a little bit. But the thing we think is really compelling about how we build our framework and how to leverage it is, we think that NiFi is great for engineers and power users to create a template. But a lot of times we found that there's many repeatable patterns for ingestion, right? You might have dozens of feeds that follow the same kind of flow. And so defining a template in NiFi and then having a simpler way to instantiate it for a large number of flows that maybe people that aren't engineers but are more analysts can configure, we think that model is really powerful. And Scott will demonstrate that for you as well, right? That role separation between defining a template and configuring and using it repeatedly for a data set. And oh, by the way, if you want to change the template, you change it once, and all of the derived flows that use that same process will have the same update, right? So that's the power of having a templating model. So overall design approach, the way we think about this is, you know, we want to support the requirements of the analyst, the steward, the data scientist, and IT operations. And it goes in a number of different ways. You know, you'll have an environment, it could be an on-premise cluster, it could be on Amazon or another public cloud. A key part of what we're doing is we believe you have to have a certain amount of metadata that's stored in a separate database that spans all the components and flows. That's at the level of feeds and dependencies. And so, you know, we actually use a relational database. It can be MySQL, as in this, and we'll see a little bit about how that works, complementary to some of the other governance technologies, metadata technologies. And then, of course, for the core processing, it leverages Apache Hadoop and Spark. And then, you know, on top, the NiFi is an essential part. So is a framework that leverages all of the capabilities in the underlying Hadoop distribution, right? So this is high level, the architecture design. Again, Scott's going to give you a lot more details as we walk through it visually, but just to give you a reference point of how it works. And it's important what we're working towards is we're looking to open source this framework later this year, right? So we're working with some of our first customers deploying this at scale. And the idea that we're going to then have it better packaged and ready to be used more broadly in the community. So we'd certainly welcome your interest and your contribution, your thoughts, and you know, stay tuned. We want to make sure when we open source it, you know, you're aware and you're ready to take a look if you're interested. And if not, at least hopefully some of our experiences, how we design it, will be relevant for you as you think about how you're moving forward in your own projects. And of course, we'd love to help you with your projects too. And you know, currently the way we're using the technology, bringing the technology, is customers we're consulting with that are basically our beta customers. So let's talk about some of the big functionality that are in here. One is, how do you do ingestion and preparation, right? So we have, complementing the NiFi visual template builder, a guided UI for helping analysts create feeds that allow you to do things like have data protection and cleansing, validation and profiling, all of which translates into Spark code that executes on the cluster. You know, the model for ingestion is, you know, we'll typically see a series of pre-built components put together. So there's a lot of them. We've created a number of data lake specific feeds that are standard, or processors that are standard NiFi processors that can do common tasks like merging and deduping data. That one actually uses Hive, or doing validation in Spark, right? So we enhanced the NiFi palette to have a better vocabulary for how do you work in a data lake, right? So Scott will show you a few examples of that in a little bit. There's also a capability, a self-service wrangling capability, so that you can visually build out some of the functionality in Spark, which again, business analysts, data scientists who are not as, or statisticians maybe aren't as much programmers will find really valuable to be able to visually join tables together, to be able to work with the data, bring in larger numbers of standard Spark functions, and increasingly we're adding machine learning functions to make it easier to do some data science functionality that can then be fed into your templates and operate. And again, that all leverages Apache Spark under the covers. And finally, data discovery, right? The ability to easily basically build Elasticsearch and then do searching and profiling and sampling of data that's in your lake. So you have that as a foundation. You deploy into this, and it's easy to add in indexing and search as part of your lake. And not to be ignored, of course, is super important is the ability to have operations be able to get a handle on what's going on. So, being able to have a dashboard and ability to look at the health of the overall system, but sliced by the concept of feeds, right? Typically what operations has in a Hadoop environment is a lot of lower level things like, well, here's a specific job and a task, and it isn't connected together in terms of here's the logical flow of how it's working together. And oh, by the way, how do the errors or delays that are happening over here relate to data confidence? As an analyst, if I want to know why, is my data up to date? And if not, why? You want to have it connected back to the feeds that led to it, right? So that ability to do that, as well as, performance reports for longer term capacity planning, are important parts of what we see, right? So I touched on this, right, with Elasticsearch. You probably are familiar with it. It's an open source project based on Lucene that lets you build, scalable search that can run right on top of Yarn. Basically, it's easy to throw in a NiFi processor to do that, and then you get the benefits of profiling, and you get the benefits of being able to search and find sample data, et cetera, in your data lake. So with that, let me turn it over to Scott to take you through the demo.
Thanks, Ron. OK, so here I'm going to go through two interfaces here. First, we're going to go through the operations module that Ron described. And then we'll go into what we call the feed manager. We'll actually get into how we integrate Apache, NiFi, and Spark together with this framework. So at the start here, as the operations manager, is this dashboard. And at the core is what we focus on is the feed health. So a feed, in the simplest form, is the movement of data either in or out of Hadoop. But there's usually a lot more that correlates to what a feed really is. You might have service level agreements or data confidence checks to check the integrity of that data. All of that plays an important role in summarizing the overall health of your data feed, which you can see here very quickly at a high level. In addition to seeing the feed health, an operations manager can also quickly see the health of their entire cluster. So clicking on the services here, you can wire in and to your existing Hadoop distribution, find any services of whether they're healthy or not, and drill in to see what their status is. Now then, the operations manager can correlate that data with the feed health data to help troubleshoot when things become unhealthy. Clicking on a given feed will bring you into the feed details page. Here at the top is a graph showing all the jobs that have been executed for that feed over time, grouped by status. Below the graph here shows all the job executions with some more details. Clicking on a job will bring you to the job details page. Now we're using NiFi behind the scenes for our orchestration engine to configure these flows and process these jobs. When NiFi runs, there's a series of setup parameters that is captured, and also operational metadata that's captured along the way. Clicking on the various steps, you can view this operational metadata that's been captured by NiFi. If any errors occur during the operation or the flow, they will be displayed here. In addition, if any errors occurred for a feed or a feed becomes unhealthy due to a service level agreement or a feed is unhealthy, alerts will be generated and displayed on the right-hand side. There's also extensive charting capabilities to do more analytics on your data. And this is a drag and drop interactive chart where you can go and produce your own charts to analyze your data. Now, that was a very quick overview of the operations tool. What I really want to get into is how we use Apache NiFi and Spark. So I'm going to jump over to the feed manager here. Here we're in the feed manager listing all of our feeds we have configured in our system. I'm going to go click on the plus, and what we're going to do is create a new data feed using our wizard, which will actually go and generate a NiFi flow behind the scenes. So I'm going to be ingesting data, so I'm going to click Data Ingest. And in this case, for this demo, I have some user data. So I'm going to name my feed Users, and then I'm going to choose a category of Online, because it's online user data. Categories help you group your feeds, because businesses can have hundreds or thousands of feeds. And you can manage these categories in a separate link over here. I next am going to be giving the feed some more details. In this case, I need to choose the input source of the data. I can choose a database or a file system. So for this demo, I'm going to choose a file system. And I have to give it the name of the file that it's looking for. In this case, it's going to be looking for a file called online users with some numeric character after it. And also the location of where that file is in this directory var drop zone. The next step here, I need to define the destination table or the schema of which is going to be created in Hive. So I can either manually create it or have the system help me. So I'm going to choose to upload a sample file of this data, and it will go and parse that data, parse the headers from that file, and produce a schema of which it best fits for that file. I then can change the data types and the schema around to fit my needs. So I'll go ahead and do that, changing the registration date time to a timestamp, and also change the credit card field I have here to a string. Once my schema is defined, I also now can choose to define any partitions I want to have on this table. In this case, I'm going to go and partition this data by a new field called year on the registration date time field, and I'm going to choose the year formula. And we'll go to the next step. In this data processing step, I can apply additional rules to this table. The first field here lets me choose what fields I want to be sent to Elasticsearch for Google-like searching. As Ron said, we have our data ingest feed profiles all of our data and the fields, generating many useful statistics like min value, max value, top end values, standard deviation, and that's all done through this checkbox here. I can choose, if I wish, to apply additional standardization or cleansing rules and validation rules to my data. So for example, our credit card, let's add a standardization policy, and we want to mask this credit card. So we want to preserve the last 4 digits, and we'll add that as a standardization rule. I also want to add a validation rule. So at the time of ingest, before it gets sent to my destination table, I want to validate that the IP address is really a valid IP address. So I'm going to choose the IP address validator. These rules and validators and standardizers are fully extensible to add additional ones very easily. Once we define these processing for the fields, I now have to choose a merge strategy. I can either choose to always replace the destination table in the data anytime I ingest data. I can choose to just simply append that data to the table, or do an append by a dedupe. So I will merge that data into that table without any duplicates. I then can choose a target format of ORC and any other additional compression options that I wish. The next step here, you're going to find additional properties that will be tracked along with your feed. So in this case, just go give a data owner, Sally Samples, and you can tag your data to help in searching. And finally, we need to schedule this feed. So we can choose a cron expression to schedule it, or we can choose a simple timer. In this case, I'm going to choose a simple timer that's going to pull the system every 5 seconds for any data that needs to be ingested. So we successfully created our feed. But let's look at really what happened behind the scenes. If you go to NiFi, what happened here is that feed that we just created generated a flow like this. Let's walk through it real quick. So at the top here, oh, it worked. Sorry. So at the top here, what's going to happen is the data is going to be ingested. First, it's going to check to see if it's the first time the feed is sent into the system. If it is, it's going to need to create the necessary HDFS folder locations in the Hive tables. Then it's going to go on and merge the data, first archiving all the raw data, so we preserve all that raw data in HDFS. And then it's going to go through the data ingestion, putting the data into HDFS, creating any feed partitions that are necessary. And here is where we execute a Spark job. So this is a processor which will go out, call a Spark job. In this case, it's going to go do the validation and splitting of the data. When this job processes, what's going to happen is it splits the data into two bins, either valid or invalid. And I'll go show you, when we go back to the feed manager, you can query this data and find out what is invalid and why it became invalid, based upon the metadata that you supplied when you created that feed via the standardization and validation rules. And now, after it validates, it's going to go do three things in parallel. It's going to go merge the data into the final destination table based upon the merge strategy you selected. It's going to send that data that you selected to be indexed to Elasticsearch. And it's going to go execute another Spark job to profile that data and generate all those statistics for you. So let's go back to Feed Manager and actually see some of that profile data. So I'm going to search for an existing feed called Customer Registrations. And I'm going to click on the Profile tab. This page here is going to list all the job executions for this feed, giving you the number of rows, how many records for that job were valid or invalid. Clicking on the stats will bring me to the stats page, and this will show you all the profile statistics for the given feed when it ran. In this case, total number of count, min value, max value, top end values. Clicking on the invalid link will show you what records became invalid and why, based upon the metadata that we supplied when we created the feed. In this case, we have IP addresses that didn't match the IP address validator. And also, under the covers, implicitly, there's schema validation being done. So this string here is actually not a valid date, so it flagged it as invalid. Later on in the demo, I'm going to show you how we integrate with NiFi and do a live demonstration of NiFi. But before I do, I want to go and show you another feature we do in integrating with Spark. So for Spark, we're going to do a data transformation. And to do that, I'm going to use two different data feeds we already have configured. We have concert venues, being where concerts were located, and the concerts themselves. What I want to do is transform that data and find all the concerts grouped by city. So in this case, I'm going to make a new data feed of a data transformation and call it concerts by city. And I'm going to go put it in an existing category called music. So now that this is a data transformation feed, I need to supply or build a query. And so I'm going to go and search for the concerts table. Now this is looking at Hive. And so I'm going to grab the concerts table and add it to the canvas. And I'm also going to grab the concert venues table and add it to the canvas. And now let's join these two tables together. And I'm going to do an inner join on the venue ID for these matching tables. For my data transformation, I don't really care about the ID columns, so I'm going to deselect those. So now I have the concerts with the event names and start times, and the venues of where they were located. So now we're going to go and generate a data set. So what just happened there? It went out to Spark, ran a query, and came back. We are sampling this data for us to do some wrangling based upon 1,000 rows. You can change the sampling rate if you want to give you more data for the sampling and wrangling. So here's our data set with the fields we selected. And we have a formula bar very similar to Excel. Except in here, this exposes pretty much all of Spark's data frame operations in a nice, easy-to-use way, just like Excel does. So let's go start wrangling our data. Let's go add a new column. So I'm going to go run the concat formula and concatenate the venue city with a comma and the venue state. And let's go call that column city state. And we'll add that. Again, what is it doing? It's going out to Spark, querying, and coming back. And this is our newly created column. Let's go add one more feature. Let's do a group by. So now we want to group by our newly created column. And let's do a count. So now this is our data set that we were looking for. We have the venues, we have the city and state of where those concerts were located, and the number of events that were in those cities. So let's go to the next step. So what would be nice now is to take this and make this a scheduled feed, of which it's run on a given interval. It will query the data, transform the data, and automatically put that into Hadoop on an interval. So let's go through and walk through. We have our destination table of the count in the city state. We'll carry on through to schedule this feed, and we'll do it on a timer. And we'll make this run every 5 hours, because I don't need it too often. So now our feed is created, is scheduled, and every 5 hours, that's going to go run and query the data and put it into the data table in Hive. What I want to get to now is how we leverage NiFi and register it with our system to create this the wizard-driven data that you've seen. So let's actually go to NiFi and create a template and then register it with a feed manager. So I'm just going to create a simple process group to give me an empty canvas in NiFi. And we'll make a very simple flow in NiFi. So NiFi is composed of different processors. So I'm going to drag in a get file processor. And I'm going to drag in a put file processor. I'm going to wire the two together. So in this demo, I'm just going to go take a file from a location and put it to some other location. Very simple feed. We'll configure the get file, and we'll have it look for an input directory. We'll do the var drop zone again that I have. And on the put file, let's go configure the directory to be temp Hadoop Summit. And let's change the settings here. Because it's my final processor, I'm going to auto-terminate on both success and failure. So now I have a NiFi flow with two processors. Let's go ahead and make a template out of this, which we can then register with our system. So I'm going to highlight the two and create a new template. We'll call it Hadoop Summit. So now let's go back to Feed Manager and go to this templates section over here. These are all the registered templates you have configured in the system. Let's go and create a new one. We can either choose to create one directly from NiFi, which we're going to do. But if you're migrating from a development to a QA to a production type environment, you can go ahead and export these registered templates with the registered metadata and it allows you to easily move templates from environment to environment. So in this case, I'm going to choose create from NiFi, and I'm going to choose the Hadoop Summit that we just created that we see here. It's set up in two sections. First, we have the input or the first processors being our source processors of input properties. What this does now is it looks at the NiFi flow, finds those processors and all the properties associated with them, and exposes them to me as a developer here to say, what should I choose to either change the value of or expose to the end user when they define their feed? In this case, we want to expose the input directory for the user. So I'm going to choose to expose input directory and allow user to define this when they're defining their feed. You can also change the render type to be any series of different render types, which will be rendered in different ways when it's exposed to the user. I'm also going to choose the file filter, so then they can change this value. And also for the put file, we might want to choose what directory they want to go and inject that to. In addition to this, the benefit of using this framework is you can inject different metadata at runtime when the feed is created. So for example, if I didn't want it to be the Hadoop Summit, but maybe I wanted it to be actually the feed name, I could do that here. And when the feed gets registered, it will inject the feed name the user defined and put that into the flow. So we'll try that. And finally, we'll go and register this feed. Give it an icon, and we'll register it. Now that we registered the feed, we can go back to the feed manager and create a new feed. So now we should see our Hadoop Summit template here, and we're going to create that type of feed. We'll call this feed Hadoop. We can go in and we'll go into any type of category here. We'll choose web data. Now, because I chose the two properties to be exposed, we have the file filter. So we'll just call this file hadoop.csv. And that's a drop zone I can override if I wish, but we'll leave it the same. And I could give it a data owner. We'll give it Sally Samples again. And finally, we'll schedule this. And we'll do another timer, and we'll do this every 5 seconds. So now we successfully created that feed. So we can actually search for that feed. And you can see it's going to be looking in the var drop zone for Hadoop CSV. What we can do now is actually go and drop a file into that location. And then go back to Operations Manager and watch that file run. So it's polling every 5 seconds, and see if it happens.
There you go.
Let's go to NiFi to see what happened. No, it actually ran it, so hang on. I think it just ran it and ran it too quick. We should look in Operations Manager how it ran. It already ran. It ran before we even got to Operations Manager. So it already ran. It got our file and actually put it in the right location. Because it was so quick, it took like milliseconds. So Operations Manager didn't even pick it up as a run, right? But you can actually query it in Operations Manager, and you can see here. It got the file and actually put the file.
It's hard to demo, it's just too fast.
So that pretty much sums up a very quick demo of how we integrated Apache NiFi and Spark and gave a user interface on top of that that helps create different data feeds.
So that gives us just a few minutes here at the end for questions.
One question I have is, can you do the incremental load, because that's a common use case which you are saying. Can I do the incremental? Suppose if I have an enterprise with 366 tables, and if the data ingestion is common, can I have a workflow and then invoke it with multiple configurations?
So,
Can I define a NiFi workflow or template and invoke that template using control M or something like that, and then by passing different parameters?
so kind of two questions there, right? You might have, you're saying you've got hundreds of tables, and you want to be able to ingest hundreds of different tables. So one, can you use the templating mechanism to make it easier to ingest hundreds of tables? And two, can you integrate it with an external scheduler like Control M?
So let's go for the integration of the external scheduler, right? So Apache NiFi has different processors that actually can listen for different events, right? So there's a couple of different ways you can actually integrate out of the box with NiFi. One being dragging in a processor that, say, is listening for an HTTP event, listening for a JMS queue, something of which that can actually trigger and get that feed, right? In addition, you can actually build your own processor to actually go in and incorporate some of that type of stuff, right? So being able to trigger off of something else, you could have a Control M script that actually writes a shell script of which you have a NiFi flow that's either looking for some location or doing something based upon that shell script, right? So that's all, you can pretty much do that out of the box with NiFi.
Can I customize? Right now, my assumption is purely Spark oriented. So suppose if I want to copy the data from the local file system into the data lake environment, right? And after that, I want to build these validations and transformations. So can I embed my own widgets in between the template?
Yeah, so NiFi is fully extensible. We've written, so if you look at the processors of what we at Think Big wrote our own, you can see these are all Think Big processors that we wrote. Apache NiFi is fully documented and open source to allow you to actually, they want you to actually use theirs or extend theirs and create your own processors to do whatever logic you need.
And one last question, sorry I asked this question. Apache Falcon also is coming out with their GUI, and they also have the scheduling, and they also have the feed concept and the lineage concept. How do you compare Apache Falcon with this? It is also a data management product, and this one is also Spark-oriented data management product. How do you compare? Is it apple and oranges, or do you compare it?
I think there's a little difference in emphasis that, Falcon is kind of grew up around doing things like replication, and there's certainly some overlap in terms of this also gives you a mechanism for handling a variety of feeds, including batch, but we think, you need more than just handling feeds, right? You need to be able to do, have richer functionality around profiling and be able to allow for transformations and allow for some different governance capabilities. So I guess I'd say that we feel like this is a very nice sweet spot, and we think the ability to define things and extend things to the NiFi concept is a powerful element here as well.
Thank you.
Thank you. Thank you. Any question there?
Are those Think Big processors available as open source, or are they, or do you have to pay for them?
So the Think Big processors, the question is, are they available as open source, or do you have to pay for them? And so they're part of this overall framework that we're going to open source. So all the processors will be included in that. But but we wanted to, I think it would be harder to open source them separately outside of the value of how they fit into this framework. I mean, in theory, they would be of some value there, but we're going to focus on packaging them. If the NiFi community liked them and wanted to make them more broadly a part of NiFi, we'd certainly be happy to say, well, have them be a contribution to NiFi. Question back there?
So his question was, does it use NiFi REST calls behind the scenes? So we do leverage the NiFi REST API heavily for how we integrate the UI with NiFi. But after you create that feed, it's actually really, what is it doing? It's creating a NiFi flow. And then NiFi is taking control, and NiFi is running and processing that stuff. Now, how we get that data back into the operations manager, NiFi has something called provenance and provenance events. We tie into their provenance event model and actually send a JMS message with that event data, of which our operations manager is receiving that JMS event and processing all the provenance data and the flow file attributes collected along the way as operational metadata that you saw in the operations manager.
Can it take care of multiple NiFi clusters?
Multiple clusters? So NiFi's REST API does allow you to go for the clustered mode. We've done heavy stress testing on NiFi, and a single, on the edge node, right, is where this is living, NiFi performs very, very, very well just in one single. So our recommendation is go for one node. If that does not somehow scale for you, yes, you can make it multiple nodes and scale out. NiFi.
Multiple tenants or multiple clusters. Like suppose you want to separate your feed based on your tenantship, create, manage multiple NiFi.
You could do that. You could have separate NiFi instances running and have separate ones fanned out, right?
Question here in the front.
Yeah. So, what does the server architecture look like for the Think Big component here? Is it just a lightweight web app that's deploying a UI, or is there some engine component that you guys have built that there's dependency on? And how does that run? Is it a Yarn container? Is it a Docker container? Is it a Tomcat application? What are we looking at?
So what's the architecture of the components that we've built?
So what you see here, this is an Angular app, and we've separated the UI from the backend pieces. So we do a proxy between the UI. So the UI could live on some other server, and then we have the backend processes that also live on some other server. Now, behind the scenes is we're capturing and storing some of this operational metadata in either a MySQL or a Postgres database, okay? Also along those lines, like I said, so really that's all, it's a MySQL or Postgres database that's storing the operational metadata for the operations manager here, and some other UI widgets for Angular that you see in the UI. And then on the NiFi flow operations, there's a JMS queue using ActiveMQ which is getting those JMS events and actually pushing that into our operation metadata store, right? We also have the metadata in the feed manager, right? And that metadata is captured in a MySQL database, but we're using the technology of a Java content repository. It's more flexible in the sense it can either go, we're storing in MySQL, but you can very easily make it a NoSQL database, and it's very easy to version your feeds that way.
All right. Well, I think we're out of time. Thank you for spending your time with us this afternoon.